So now we're going to have a quick look at how we can use prime factorization to find the square roots of perfect squares and perfect cubes. Just to recall, numbers that are perfect squares you should know: 1, 4, 9, 16, 25. Well, why are they called perfect squares? Well, any number that can be the area of a square with a side length that is a whole number. For example, we have the area of this square being 1. If that's the area of that square, then the side lengths are 1 by 1. 1 times 1 is 1. Area of a square is 4. Side lengths would be 2. 2 times 2 is 4. Side area of the square is 9. Side lengths would be 3. 3 times 3 is 9. So those are perfect squares. Square root. A number which when multiplied by itself results in a given number. For example, 5 is a square root of 25 since 5 times 5 is 25. We actually call the positive root the principal root. You might come across that term in some of the questions that you see, so just so you know that. Example 1, determine the square root of 1764. Now, these types of questions you should actually be able to do, for the most part, without, W/O means without, your calculator. Now, it used to be in the provincial exam that there actually is a no calculator section. I'm not sure as a department if we have decided yet or not if there's going to be a no calculator portion of the final exam. But for the purposes of some of these questions through quizzes, I'm definitely going to make you try some of these without a calculator. So determine the square root of 1764. We do the whole prime factorization thing again. We start with our tree. I know that 1764 is an even number, so it's going to divide by 2. That's going to give me 882. Again, it's even, it's going to divide by 2. That's going to give me 441. Well, I've seen 441 before. I know that's going to divide by 3 to give me 147. And 147 by 3 is going to give me 49. And then, of course, 49 is 7 times 7. Wow, that was fast, hey? So our prime factorization for 1764 is 2 times 2 times 3 times 3 times 7 times 7. There's our prime factorization. Now, if we're trying to find square root, we want to take that prime factorization and split it up into 2 equal groups. Which means, erase that, which means what I'm going to do is I'm going to say, okay, my green ones are going to be one group. There's a 2, there's a 3, there's a 7, giving me 2 times 3 times 7. And then my purple ones are a second group, 2, a 3, and a 7. So 2 equal groups of 2 times 3 times 3 times 7. And when I actually do multiply those out, I get 42. So the square root of 1764 is equal to 42. Okay. Now, again, I can also show that by saying, well, square root of 1764 is equal to the square root of 2 times 2 times 3 times 3 times 7 times 7. And knowing that we're taking the square root underneath our root sign here, I look for pairs of numbers. So here is a pair of 2's, here is a pair of 3, here is a pair of 7. When I take the square root, that's going to give me 1, 2. When I take the square root, that's going to give me a 3. When I take the square root, that's going to give me a 7. Well, 2 times 3 times 7, 42. Square root of 1764.